So hi everyone, in this video we are going to discuss about the FCFS na algorithm or the first come first served scheduling na algorithm. So by far this is the simplest na algorithm there is, and with this scheme the process that requests the CPU first is allocated the CPU first. So the implementation of an FCFS na policy is easily managed by an FIFO or first in, first out na queue. So it is served in the order of arrival. So for example, in here, task A has arrived first, followed by task B, and then the task C. So what would be the order in which this task will be executed? So it will be A, then followed by B, and then followed by C, since they have arrived first. Okay, so here's an example. Assuming we have three processes, P1, P2, and then P3, and are served in the FCFS na order, wherein P1 has arrived first, followed by P2, and then followed by P3, and they all arrive at time 0. Okay, so the burst times of P1 and P2 and P3 are 23, 3, and 3 na milliseconds, assuming, right? So since that P1 has arrived first, then it gets to be executed by the CPU first. And we have mentioned here that its burst time, or the time that it gets to execute, is 24 seconds, right? Then it will be followed by P2, since P2 has arrived second, and its burst time is 3 milliseconds. So we have allotted 3 milliseconds for it also. And then the P3 is executed next, since P3 has arrived after P2, and it has also a burst time of 3 milliseconds. Okay, so what would be the waiting time for each na process? So the waiting time for P1 is 0, since there are no other queued na processes before it, and it arrived first, so it already got executed immediately. So its waiting time is 0. For P2, the waiting time for P2 is 24, since it has to wait for P1 to complete its execution, and P1 took 24 milliseconds to execute. Now, for P3, it's 27, since it has to wait for P1 and P2 to complete its execution, which took a total of 27 milliseconds, since P1 and P2 has burst times of 24 and 3 milliseconds. Okay, and to compute for the average na waiting time, we simply have to sum up all of these waiting times. So 0 plus 24 plus 27 divided by the total number of processes that we have, in which in this case is 3 na processes. So it is equivalent to 17. And what about the turnaround time? So we mentioned earlier that the turnaround time is the time of submission of a process to the time of completion. So all of these processes have arrived at time 0. Okay, so for P1, the turnaround time is from 0 to 24. Okay, so since it started from here, it arrived at time 0 and it got executed at 24. So don't be confused about that they all arrive at time 0, but then P1 arrived first, and then P2, and then P3. Okay, so for P2, its average na turnaround time, its turnaround time is 27, since it also arrived at time 0, and it finished its execution at 27 na millisecond. How about for the third na process? So the third na process, or P3, also arrived at time 0 and finished its execution at the 30th na millisecond. Okay, so that's why the turnaround time for P3 is also. Now, To compute for the average na turnaround time, we simply have to sum all of this up. 24 plus 27 and then 30 divided by 3, which is equal to 27. Now, what are what insight can you get from this algorithm? Okay, so there is the waiting time for P2 and the P3 are very long, correct? Since P1 got to arrive first and it took for P1 24 seconds. So even if the burst times of P2 and P3 are very short, like only 3 seconds, they have to wait for a long time before they take a turn into the CPU. Okay, so it's really not a good idea to use FCFS if you have really long na processes that got to arrive first. Okay, so we also have the convoy effect. What if the order of the process, the arrival order of the processes has changed? So in this case, what if P1, P2, and then P3 got to arrive first, followed by P3? Okay, so note that the burst times are the same. P1 still has 24 milliseconds, followed by P2 and then P3 na 3 milliseconds. So this is the order now. Okay, P2, then P3, and then P1. So in this case, the P2 gets to execute first since it's arrived first as well. And P2 has a burst time of 3 milliseconds. What about the next process? So the next process that will be executed is P3 since it arrived the second and it also executed for 3 milliseconds, followed by P1, which arrived last and it executed for 24 milliseconds. Right? So what would be the waiting time? For P1, the waiting time is 6 milliseconds. Okay, since it has to wait for P2 and P3 to complete its execution before it started its own. And for P2, the waiting time would be 0 since it arrived first and it already got executed the moment it arrived. And for P3, the waiting time is 3 since it has to wait for P2 to complete its execution, which took 3 milliseconds before P3 started. So how do we compute for the average waiting time? So similarly, we simply have to add this all up divided by the total number of processes that we have, which is equal to 3. All right. And for the turnaround time, what's the turnaround time again? So simply said, turnaround time is the completion time, okay, or the interval from the time of submission of a process to the time of completion. So for P2, we have to assume that all of these processes arrive at time 0. Okay, time 0. Now, we simply have to subtract the time it got completed minus the arrival na time. Okay, so for P2, it is 3 minus 0. Okay, that's why for P2, its turnaround time is 3. And then for P3, it's 6 minus 0. That would be 6 milliseconds. And for P1, it completed at this period, at the 30th millisecond. So 30 minus 0, that would be 30. Okay, so in order for us to compute for the average turnaround time, we simply have to add this all up divided by, again, the total number of processes, which is equal to 3. Okay, and compared to the previous na algorithm wherein the previous na example wherein P1 got executed first, at this point, since P2 and P3, which are much na shorter na jobs, and got to arrive first, now the average time has sufficiently improved. Okay, and the turnaround time has also improved, so it is much better. So before, it took 27 milliseconds when P1 got to arrive.